And then maybe I'll just stare at this screen then, if you guys don't mind. Okay, so first, motivated reasoning. Let's just briefly discuss it. And again, feel free to interrupt me if you have questions. But to psychologists, this is kind of a pretty well-known phenomena. It's like maybe the most, or one of the top, I don't know, 2 or 3 robust, well-documented social psych phenomena. Along with things like cognitive dissonance. It's like really, really well studied. So Kunda, I guess this is pretty small, but that review paper at the bottom corner, can you guys see my pointer sheet? Yeah. So that review paper, covers, I don't know, 1,000 different studies, like a huge number. And it's a really good review by Kunda. But, motivated reasoning is just the idea that we believe what we want to be true. And so things like, you think you're more attractive than you actually are, you think you're smarter than you actually are, and in fact, everybody thinks they're better than they actually are and better than average. So you have these like classic better than average effects where like you ask people like how good they are at driving, and like 80% of people think that they're better than the average person at driving. And that's true if you replace driving with anything. So that's like one of the classic illustrations of overconfidence. Attitude polarization, that's kind of a related phenomena, which also comes from motivated reasoning, mostly applied in like political domains. But like if you like give people like ambiguous information about their favorite like political issue, I don't know, prison reform, like how good is capital punishment. If you take people who are like in favor of capital punishment and you give them the same set of studies as people who are against capital punishment, like they become more polarized once they read these studies. So everybody kind of reads these studies, and like the people who like are against capital punishment like finds like huge flaws with it and are like, oh well, this only like really conforms to my priors and makes me like totally think capital punishment is even worse than I thought. And the people who favor capital punishment read the same set of studies and are like, well, this is super compelling, wow, I didn't even realize like capital punishment is like even more important than I thought. So after reading ambiguous evidence, because we read them in a motivated way, you can become even more extreme. So that's another kind of classic illustration of motivated reasoning, and you can kind of see how bad it gets in the political domain, but also like for self-representation and stuff. So we use very kind of biased reasoning processes to evaluate all sorts of things. Okay, so there are 3 very particular ways in which motivated reasoning works. So one way is when we see evidence that is like favorable to like what we want, we incorporate that evidence. But when we see evidence that's unsupportive, we kind of ignore it. So there's a lot of good evidence of this kind of thing. So, a classic econ experiment had people take an IQ test and they got a score. And at first they kind of like were told to like guess how good they would do. And if the score was like better than they first guessed, then people were like, oh, wow, like this is such an amazing test. And then you ask them to like re-estimate and they estimate even higher. Okay, but if you give them a score lower than they initially guessed, they're like, oh, this test is like really stupid. And they totally discount it and ignore it and stick to the old priors. So your priors kind of adjust upwards when you get a good signal, but they don't adjust at all when you get a bad signal. So that's one kind of mechanism by which we have motivated reasoning, is we incorporate good information and we kind of overlook bad information. Okay. But like some of the other mechanisms for motivated reasoning that we're going to get into, this kind of raises the question of why is it so easy for us to like overlook unsupportive evidence, but at the same time, we attend to the supportive evidence. We don't just like make it up. We don't just like act as if it's there. We respond to it. So we go up when we see supportive evidence, but like we don't just act as if we have it when we don't. So there's a real asymmetry between like having supportive evidence and versus lacking it. Like that makes a difference. But having unsupportive evidence versus lacking it, we treat those the same. So we're responsive to supportive and not to unsupportive. And that's a bit weird why we do it that way. Like if we can lie to ourselves about like whether or not this non-supportive evidence is there, why can't we lie to ourselves about whether the supportive evidence is there? So this is kind of like what Iyad was saying. This is a classic puzzle that like it's like a key mechanism by which we do something really weird, motivated reasoning. And it's not at all obvious why there's this fundamental asymmetry between how we treat positive and negative evidence. If we're just going to lie to ourselves, why do we lie to ourselves in this particular way? Okay, so one more way in which we lie to ourselves, in which motivated reasoning works. So I don't know, there's this classic study by Ditto and Lopez, which has people like put a test strip in their mouth and they're told that it'll turn green if they have this like debilitating disease or whatever. And another set of subjects are told that the test strip is going to turn green if they don't have the debilitating disease. Okay, so in one case, turning green is a good sign, and in another case, it's a bad sign. Okay, so for the subjects who are told it's a good sign, they leave it in their mouth for a lot longer. Now, the psychologists are lying to them. The test script doesn't do anything. It's just, it's just like a piece of paper or whatever. But if they really want it to turn green because it's a good sign, they wait really long. Okay, but if they don't want it to turn green because it's a bad sign, they put it in their mouth and they pull it out like 2 seconds later. Okay, so we're searching really, really hard to find evidence that we like, whereas like evidence that we don't like, we aren't searching for at all, which is again, that's one way in which we kind of fool ourselves. We search harder for the stuff we want than for the stuff we don't want, but it's still a bit weird that we do it this way, because like if you think about it for a minute, what that says is we're able to ignore how hard we actually search for the information, but we're not able to ignore what we find. So you can kind of ignore the fact that you left the test strip in your mouth for like 2 seconds or for like 5 minutes, but you can't ignore whether the test strip changed color. So why is it that we're able to kind of ignore some type of information and not another type of information? So why does motivated reasoning have this like weird feature? Okay, so that's kind of a second puzzle about motivated reasoning. Finally, a third thing is we run confirmatory tests. What do I mean by confirmatory tests? Like tests where you're like, looking for supportive evidence, but the tests kind of are going to give you that supportive evidence, like regardless of what the underlying truth is. So for instance, like, you ask your friend, like whether you look good in an outfit or whether or not like you're the one at fault in like your recent breakup. Like your friend's obviously going to tell you you look great and like, no, it was your partner who was at fault. Like, but like, and you even know like your friend is like a biased source and yet you're still asking them. So like, why is it important to like ask them when like the information they give you is going to be like positive either way? Like, how is that a valid source of information? But we do this all the time. We run kind of confirmatory tests, like asking our friend's opinion all the time. And so that's a bit weird. And again, like the other ways we use motivated reasoning, it's weird in that we're able to overlook the fact that the test isn't particularly informative, but we're not able to overlook what the test results are. So like, it's not like we can just like ask somebody who hates us and then pretend like they said something positive. So we can't like pretend to ourselves what the result is, but we can pretend that our friend is unbiased. So again, there's this weird asymmetry in the way we're able to deceive ourselves, and that's a bit puzzling. Why there's this particular asymmetry? Okay, so those are 3 puzzles about how motivated reasoning works, and we're going to present a set of models that tries to address them. But first, let me take a detour and talk about spin. And the key is that the models are actually going to explain both the set of puzzles about motivated reasoning as well as the set of puzzles about spin. Okay. Okay. So for spin, spin, I guess maybe you guys don't use that word so much in other languages or in Germany, but all I mean by spin is like not like lying or like making up information, but presenting information in a very biased way. I guess if you listen to any like political pundit, so this is Bill O'Reilly, he had this TV show on Fox News that was quite famous called The No Spin Zone. And it was, of course, like every TV show about politics, especially on Fox News, completely spin. And what he's doing is, he's presenting information about political stuff, usually without lying, but like very, very selectively. Okay, so, but we do this too. We do this, if you on your dating profile, you're going to say like all these like great things about yourself. You're not going to give like an objective assessment of how good you would be as a romantic partner. So we're spinning too. And, we also spin our research. So like, your university press office, when they talk about your recent publication, they're not going to talk about like the limitations of the publication. They're going to talk about like why it's going to change the world. So, your press office is doing it. The about page of like every organization spins. So spin is kind of all over the place. And in some cases, it's more costly than others. So I guess like, maybe it's not such a big deal if like, my press office spins like some silly game theory model, like nobody's going to be hurt by that. But like if I was doing medical research, people can be hurt by that. And there's very good evidence that when medical research does get spun, it can lead to like really bad problems. So this one PNS paper from a few years ago reviewed the medical research and like the way it gets spun, and then talks about some of the like real negative consequences. Like people end up taking their own drugs because of like papers that they read or their doctors read and recommended to them. And, papers that get a lot of press, make it into like the New York Times, they can end up like really distorting stuff. Okay, and so other ways in which spin can be like quite deleterious is sometimes in the effort to spin, we can mess with really valuable stuff. So for instance, Trump really didn't want the case numbers for COVID to be high in the US. And so what he did was he tried to restrict the ease by which Americans could get tested. And in Europe, you have really, really good testing and you have really good track and trace. In the US, for a long time, we didn't have that. It was quite expensive to get testing and quite hard to trace. And of course, that's going to make that'll make the case numbers look lower, which made Trump look good. But it of course makes COVID a lot harder to contain. So spin can be really costly in that it can make it really hard for people to get really useful information. Okay, then lastly, obviously, it can help us lead to like very, very bad decisions. So anybody who was following, I don't know, in the early 2000s, like the lead up to the Iraq War, I guess it wasn't spun so much in Europe. You guys were getting decent information about it. In the US, it was being completely spun by both the media and by the Bush administration about, the ties between Saddam and Al-Qaeda and, his weapons of mass destruction program. And the Bush administration was using the intelligence community to both gather information and to spin information about these connections. And we were getting a very distorted view, and most Americans supported the war, including Democrats in Congress, who had internal qualms because of the spin and because of American public opinion. They ended up voting in favor of it, and obviously that led to very deleterious effects for the world. Okay, so spin could be bad. Fine. So similar puzzles about spin. Okay, so one puzzle about sorry, not puzzle. Similar features of spin, similar ways in which people spin, which are going to be somewhat analogous to the ways that motivated reasoning works, is we choose kind of what topics to talk about. So this is one really nice website which allows you to plug in any search term, and it'll show you like the frequency in which that term is used on chyrons. Chyrons are like the little like information bubbles during like news shows that like summarize the news that they're talking about. So you can kind of look at what words show up in these chyrons. That's kind of a measure of like how often these topics are discussed on those news shows. So 3 news shows, Fox News is right-leaning, MSNBC and CNN are left-leaning. You can look at words like Russia, how often they showed up on these channels. Russia, Trump was implicated in, with collusion with Russia, and that was a big talking point on the left-leaning shows, never talked about on Fox. Okay, Benghazi, on the other side, that was a supposed scandal that Hillary Clinton, the Secretary of State, was involved in. She was blamed for the American diplomats being killed in Benghazi, and Fox News wouldn't shut up about it, whereas MSNBC and CNN never talked about Benghazi. So the way that spinning is working here is in the selection of what you talk about, Russia or Benghazi. Okay, so another way that people spin, again, I'm talking about the media a lot, but I guess that's a consequential and common case that spin shows up, is stories get killed. So this is one example of a story that got killed right before the 2016 election. Trump paid off a violation of campaign finance laws in the US, paid off Stormy Daniels, who was a porn star that he had an affair with. So he paid her off to kill the story. And Fox News found out that he paid her off for her story so that she wouldn't go to the tabloids with it. And of course, campaign finance laws, also, sexual mores in the US, that most people think that would have killed his campaign. And Fox News wanted him to win the election, so they killed the story. Okay. And so there's good evidence that Fox had the story. Some of their anchors were planning on running with it. And all the way from the top, Rupert Murdoch, who owns Fox News, told them they can't talk about it. So that's kind of another way in which we spin, killing stories that are unfavorable to us or our team. Okay, so another way we spin is what evidence we search hard for. So again, kind of analogous to the Ditto and Lopez test strip study. So Cheney looked really, really hard for evidence of things like, yellow cake uranium. And when he was told that actually they probably, didn't actually buy the yellow cake, I went to Niger and found nothing. People at the CIA were told not to look into that anymore and to fire the person who was claiming nothing was involved there. But when they were told that there was evidence to look for, even if it wasn't that substantial, Cheney said, okay, get on it, find more, find more, find more. So they're investing all sorts of resources into searching for the good stuff or the stuff that's good for their case. But anything that could be bad for their case, they're immediately telling people don't look into that. So asymmetry in what you search for, not just what you present. Okay, so finally, one more way in which we spin, then I'm ready to move on to the models, is we cherry pick. So this, oh, you guys, oh shoot, you guys keep seeing their faces. Okay, so sorry if that was covering important stuff before. Okay, so this is a classic graph that's used by climate deniers. So this is actual data of like climate change over the course of, I don't know, the last 40 or 50 years. And as you can see, there's a lot of variability in temperature. And this graph, the part up top here, that's just in white, is what was shown on the US Senate floor by people who are denying climate change. And if you look, starting in, what is that, 1998 up until 2008, which I guess this was shown in 2010, but up until 2008, actually, like, the temperature is dropping. So there's a negative slope here. The world is getting cooler during that time period. So, this was presented on the US Senate floor to say, like, look, we shouldn't actually be doing anything about climate change. It's not a problem. If anything, it's like going in the opposite direction. Like, climate change is a hoax. Okay, but of course, that only works because you chose this as your starting year and this is your ending year. If you look at the full graph, what you see is there's variability from year to year, but the total trend is upward. And only if you very, very carefully, pick your years, cherry picking, will you get something downward sloping. But this is like a common trick that you use when you spin. You cherry pick your data, or the way scientists do it, they p-hack the data. So you run a bunch of regressions until you get the one that has the p-value that you like. Okay, and so what p-hacking and cherry picking are doing is they're making sure that you can get supportive results regardless of the underlying truth. So if the yearly temperature varies enough, then you can find years where it's cooling, which is supporting evidence if you're trying to deny climate change. But that's because if you're able to pick the years and there's enough variability, you're kind of you're making sure that you can get supportive results regardless of the underlying truth. And the same thing with p-hacking. If you run enough regressions, you can get significant results regardless of whether or not your hypothesis is correct. Okay, so those are some ways in which we spin. Hopefully you already see there's some similarity between that and the way that we do motivated reasoning. Okay, so fine. This raises the questions. Why do we spin in these particular ways? Just like we asked about motivated reasoning. When will we spin in these particular ways? And finally, okay, and finally, another really puzzling thing about spin is people know that we spin. Like, everybody knows that Fox News is selectively killing stories and only talking about searching stories, and MSNBC and CNN doing the opposite. And everybody knows that, like, we cherry pick data. And I don't know. So here's an example of everybody knowing. I Googled letter recommendations, and it everybody knows that you always say really positive things about your student that you're writing a reference letter for. But so do the people who are reading the reference letters. They know to discount it. And so this one site, tells you, I don't know, this is just what you find on Google. And my whole point here is, like, everybody it's just common knowledge that, like, this is what the reference letter says. They might say, he has made an effort to meet our requirements. Everybody knows what that actually means is insufficient. He's actually, like, quite bad. And so we're all kind of inflating, we're all kind of spinning, and, like, people know that that's not how. You don't read reference letters literally. You don't, you assume that the person who wrote the letter is, like, being overly positive. People, even when they read your research papers, they assume that, like, okay, you probably, any study that didn't work out as well as you would have liked, you stuck in a file drawer. So, like, people know that we p-hack, and people know that we cheat in all sorts of ways, and yet we still do it. So why is it worth doing, even though everybody kind of, like, anticipates it and is aware of it and is adjusting for it? So that's kind of the key puzzle when it comes to motivated reasoning. Okay. I know Yad promised that I'd be, like, more excited. I usually am more excited about my research, but I guess talking on the screen and sitting down maybe kills the and I can't interact with you guys so much. But maybe now's a good time to stop and see, is everybody with me? I guess I'm going to talk about the model tied to motivated reasoning, and first I'll have a brief interlude about game theory. That's the rest of the talk, but maybe, yeah, now's a good time to stop if anybody has questions or wants to prod. I think I'm about halfway done. Are we good? Okay. Okay. So fine. Game theory it assumes all sorts of ugly things, like that people can, solve for Nash equilibrium in their heads, and that they can use Bayes' rule. And like arguably that works really well if you're like, in a Dutch auction or in a boardroom with a lot of money on the line, or if you're like Henry Kissinger and like really Machiavellian, like, okay, these people maybe are like doing what Nash suggests. But like, obviously, like that raises the question, why the hell am I using Nash to talk about motivated reasoning or people who are watching Fox News? Okay. Or Bill O'Reilly, the people on Fox News. Okay, so I'm not actually going to assume people are smart, and I guess maybe I'm preaching to the choir here. Everybody in this audience maybe is familiar with this way of thinking. Like Yad said, like we don't actually need to assume people are like consciously really good at calculating things to think that things like game theory is gonna be sensible, because well, people can learn, and learning processes are quite smart, and people evolve, and evolution is quite smart. So even if the people aren't consciously able to be smart, they can still be very responsive to things like Bayes' rule and Nash equilibrium. So that's the basic premise that underlies all of my research, and I guess true for many of the people in the audience here. I guess a lot of like the adaptive rationality group also thinks in a similar way, which is things might look stupid, and maybe like consciously we're not fully aware of what's going on, but like evolution and learning processes get us to do really smart things. So okay, reinforcement learning, social limitation, biological evolution, they get us to do fancy stuff. Okay, I guess for this audience, I don't need to go into that. But so I'm still going to use game theory tools like I do in all my research, not assuming that people are consciously able to calculate, these kind of things, but assuming that nevertheless they'll develop heuristics and they'll develop like intuitions and stuff that are still consistent with Nash. Okay, and so Nash will be able to help us better understand our emotions, our heuristics, our intuition, stuff like that. Okay. So fine. Now I'm going to get into the models. So the first one, well, first some background discussion, which is all the models are going to take place in a persuasion setting. So let me define what a persuasion setting is. You guys, I guess I can't see all your faces, but I see 4 people on the screen and 4 people here, but you guys are all familiar with game theory, right? Okay. And it's safe to assume that everybody in the audience at least knows the basics. Yeah, okay. Maybe some more than others. Okay, but so maybe you've already seen like notion of persuasion formalized. Uh-oh, that got cut off. Uh-oh. So that's that should say H and L. Okay, that H got cut off. But there's in a persuasion setting, there's 2 states, high and low, and I guess I just made the circles, the circles are different sizes to represent their prior probability. So like bigger circles, happen, I don't know, 70% of the time. Okay, so states have priors, and then there's 2 players, a sender and a receiver. And then the key to a persuasion setting is the sender's preferences are such that the sender wants the receiver to think that the high state is very common. Okay, so whether the high state is a bigger or smaller circle, the sender wants the receiver to think that it's a big circle. Okay, the sender wants the receiver to think it's the high state. Okay, so I don't know, on your dating profile, that would be a persuasion setting. You're trying to persuade the other person, who's matched with you, that you would be a good romantic partner. So the high state would be you're a good romantic partner. The low state is you're a bad romantic partner. The sender is the person who made the profile. The receiver is the person looking at the profile, and the sender wants the receiver to think that you're a good partner. Okay, so that's an example of a persuasion setting. Okay, so how evidence works. So the key to all the persuasion settings, that we're going to discuss today is talking about how the sender exploits evidence to affect the beliefs of the receiver. Okay, so evidence is going to be the key tool at the sender's disposal to be able to persuade the receiver. So let's discuss how evidence works. That's going to be our second main piece. Okay, so evidence may or may not exist. Okay, so exists, doesn't exist. Its likelihood of existing depends on the state. So I don't know, it's got a 90% chance of existing in the high state. It's got only a 20% chance of existing in the low state. Okay, so oops, sorry. So that's the way evidence is defined. It's a specific type of signal that only takes on 2 values. It exists or it doesn't, and the odds that it takes on these values is a function of the state. Okay. So that's why it's indicative of the state. The evidence here would be evidence for the state being high because it's more likely to occur in the high state. Okay. Can I make this smaller? Well, okay. Sorry, guys. So one other feature that's important in evidence is that the sender, the person who obtains the evidence, they can choose to reveal it if they have it, in which case the other player will be able to see the evidence, or they can withhold it, in which case it'll look like no evidence exists. Okay, and so the sender can freely choose to transmit the evidence, or he can withhold it. That's kind of key. But what's important is he can't fabricate the evidence. So there's no way to go from here to here. There's no way to pretend you have evidence that you don't. There's a particular feature of how evidence works. It's not fault. You can't fake it. Okay. And you also can't prove that you don't have it. So there's no way, in this case, to prove that I didn't just have the evidence and choose to withhold it. Okay, so the receiver won't be able to discriminate between the two arrows coming in here, whether it's evidence is withhold or it just never existed. Okay, so this is kind of key. This figure here is a key property of evidence is you can't fabricate it, you can withhold it. Once it's withheld, it's really hard to. There's no way to prove that it was withheld, and as opposed to that you just didn't have it in the first place. Okay, so that's how evidence works. Any questions about this slide before I move on? I guess this slide is somewhat crucial. So in game theory, there's all sorts of different signaling models, and there's like all sorts of different assumptions you can make about signals. So like costly signals are ones that like anybody can send, but it just costs money to send, and it might cost some types more money than others. Okay, evidence is a different type of signal. It's not a costly signal. It's one that's free to send, but you can't fake it. And you can verify when you have it. But you can't verify that you don't. Okay, so evidence is kind of a unique type of signal. We'll come back to it if it's a little bit confusing, or if that property when that property shows up. Okay, so there's three choices that we're going to consider. Okay, so one choice is the sender's decision of like how much to search for the evidence. Okay, so we assume that it costs some amount to search, and if evidence exists, then you only find it if you search for it. Okay, but if it doesn't exist, whether you search for it or not, like you'll never be able to come up with something. Okay, so searching helps you find evidence that exists, but it doesn't affect evidence that doesn't exist. So one choice will be how hard do you want to search. So do you want to send the entire CIA, on a mission to find a connection between Saddam and Al Qaeda, or do you just want to not bother looking into it? Okay, so that's one decision. How much do you search? Okay, another decision is what kind of evidence to generate. So what kind of test to run. So, for instance, you could p-hack, which will slightly change the odds of evidence being generated in different cases. So p-hacking, is the blue bars, as compared to the gray bars. So the blue bars differ from the gray bars in that the odds of generating evidence are higher, both in the low state and the high state. So these bars are thicker. The thickness of the bars corresponds to the probabilities. So thicker bars going into evidence, that means by p-hacking, you're making it more likely you get, a significant result, regardless of which state you're coming from. Okay, so regardless whether you're coming from the high state or the low state, these bars are now thicker than the gray bars. That's what p-hacking does, is it increases the thickness of those two bars. Okay, so one choice that you can make is the exact way evidence gets generated. You can sometimes mess it. Sorry, I don't know why the back button goes to the previous slide. Sometimes you can mess with the thickness of the bars by messing with the way evidence gets generated in the first place. Okay, and so one question we'll ask is like, when do you search, and when do you do things like mess with the way evidence gets generated? Okay, and then finally, like before we talked about, when do you reveal evidence? Again, you don't have the option to reveal evidence that you don't have, but evidence that you do have, you could reveal or you could withhold and pretend like you didn't have it. So when are you going to make this choice? So those are the three strategic decisions you're going to make. And we can ask in a game theory model, in equilibrium, when are you going to make these? When are you going to search? When are you going to reveal? Which evidence are you going to try to generate? So fine. The key assumptions in these models are going to be that I mentioned this already. You can't verify lack of evidence. You can only verify evidence that you have. You can't prove that you don't have evidence. That's key. People can't observe how hard you search for things. So it's really hard for us to know how much Cheney spent looking after yellow cake uranium. or aluminum tubes. Like, we know that he found them. He shows us photos of them. We don't know that he sucked the entire CIA on it for several years. So it's a little bit hard to verify how hard people searched. And finally, we can't tell exact details of what tests you ran. So we know what regression you report in your paper. It's pretty hard to know what regressions you ran before deciding which one to go with. Okay. And the same with your studies. Like, you could have a bunch of studies in your file drawer. We can't really know all the studies you ran. We can only know the final results that you reported. Okay. So the exact test that you chose to run, it's a little bit hard to tell. Okay. But in contrast to all these three assumptions, the results we assume can't be faked. Okay. So we assume you didn't Steeple was his name. He made up his data. We assume that researchers don't do that, but it's really hard to know how much the p-hacking. It's a lot easier to know if they fake the result. The punishment for faking is also a lot bigger. So anyhow, in the model, it's just assumed that you can't fake, and but you can choose, to do things like p-hack. Reality obviously is somewhere in between like these assumptions and this assumption, but the point is kind of a relative claim, which is like it's a lot harder to observe these things than it is to fake the results. Okay, so these assumptions are necessary for all of our models to go through. Okay, and I guess all of this, the whole talk, by the way, is based on 2 book chapters that we posted online. Wherever this talk was advertised, the book chapters are there, and it goes through evidence for these assumptions and kind of talks through them a little bit more. And I guess one of the nice things about like these game theory models is like they really help you understand what assumptions are driving the results, which A, then you can ask how reasonable are the assumptions, but B, you can also then ask, okay, what happens when the assumptions are violated? Like, the game theory model should predict then that you should see less spinning or less motivated reasoning in those cases. To the extent that the model is correct, when the assumptions are violated, then so should the phenomena the assumptions are being used to explain. So anyhow, we talked through that a bit. So we talked through exactly what these assumptions are, exactly how reasonable they are, then cases where they're violated. Okay. By the way, I guess the book, this is 2 chapters from the book. The book is coming out in like April, and the book is just like, I don't know, it's like 10 models like this. So like this talk would be like, it's like 2 chapters in the book. And we always go through puzzles, and then we go through like models, and then we go through like evidence, like what I hinted at here. Okay, cool. So some key questions. Am I doing on time? I think I have like 10 minutes left. Yeah, okay, I should be okay. So the key questions I mentioned: when do you reveal? When do you search? What tests do you choose? So we already talked about that. Here's the key results. Okay. So you only search and reveal supportive evidence. Okay. What do I mean by supportive evidence? That's evidence that's more likely to be generated in the high state. Okay. That's the definition. And then what tests you run? You only run tests that are confirmatory, not diagnostic. What do I mean by confirmatory? I mean that they maximize the likelihood of generating evidence even in the low state. So let me go into each of those points in a little bit more depth. But first, let me mention that these both hold true even when the receiver fully anticipates what you're doing and interprets it accordingly, and it's a Bayesian Nash equilibrium. Okay, so it's not like the receiver is being fooled. The receiver knows that you're just running confirmatory tests. They know you're only presenting supportive evidence, but you still can't benefit by deviating. Okay. And I guess, given the length of this talk, I'm not actually going to prove this result or show it to you in that much more detail. But again, the book chapter goes into it more. It gives you the algebra and gives you the setup a little bit more formally. Okay, so so supportive, as we said, that just means, here's the definition. I mean, it's pretty straightforward, but the probability that evidence existing in the high state, so conditional on the high state, that probability is higher than the probability that evidence exists in the low state. Okay, so it's simple ratio of conditional probabilities. Okay, and then like diagrammatically, all that means is like evidence that's supportive, the ratio of these 2 bars is bigger than the ratio of these 2 bars. If it's non-supportive, this ratio is lower. Okay, so that's all it means for something to be supportive. And like what it means in terms of like a Bayesian who sees the evidence as well. If you see the evidence, you're going to increase your priors above what they used to be the moment that you see the evidence if it's supportive, and you decrease them if you see the evidence and it's not supportive. Okay, so this definition just corresponds to like the basic intuition that supportive evidence increases your priors. Okay, so what did I mean by confirmatory a confirmatory test, well, it just maximizes the total likelihood of the evidence occurring. Okay, so it's just the probability of evidence occurring weighted by your initial priors. Okay, and so what you're doing is you're maximizing the chance that the evidence exists across all possible states, given whatever your priors are that the states occur, which is a bit of a weird thing to do because you're just trying to make sure the evidence shows up. You're not actually trying to make sure the evidence is like informative. So if you actually wanted to maximize how informative the evidence is, you'd maximize something like this: the difference in these two conditional probabilities. So you'd want to pick evidence. You'd want to run a test that makes sure. Here, maybe it's easy to see diagrammatically. You'd want to pick a test that makes sure the evidence shows up in the high state with a very high probability, almost no probability, will the evidence not show up. Whereas in the low state, it would you'd want to make sure the evidence doesn't show up. Okay, so a really diagnostic test has these two bars, going in totally different places. Okay, whereas a confirmatory test, the one that people actually will run in the game theory model, is one that leads to evidence regardless of the state. So this arrow is big and this arrow is big. They're both pointing in the same place. Okay, so that's very different from a diagnostic test. Okay, and if you think about like p-hacking and cherry picking, well, I kind of already described it this way. It's doing this. It's trying to make sure that you get results that confirm your hypothesis regardless of the underlying truth. Okay, so anyhow, that's formally what the thing gets maximized in equilibrium. It's this and not this. Which this is what you would maximize if you care about like informing your audience. Okay, or if you were a researcher who genuinely wants to find the truth, you'd run experiments and regressions that do this, but instead we're doing this. Okay, so finally, so that explains all of our key phenomena. You search really hard for supportive evidence, you only reveal supportive evidence, and you run tests that maximize the likelihood of obtaining supportive evidence. Okay, fine. So let me briefly return to motivated reasoning. I'm almost done, 3 or 4 more minutes, sorry. Are we okay? I guess, yeah, you guys don't mind if I take 3 or 4 more minutes? That's okay. Sorry about the technical issues at the start. So to get at motivated reasoning, we're going to use the same models of spin, but we're going to take 2 additional steps. So the first step is to ask, what would the sender actually claim she believes? So if you ask the sender in these different models, like, what do you think is the truth? What would the sender tell you? Okay, so we're not yet going to talk about what she actually believes. Let's just talk about what she would claim to believe. Okay, so 2 facts about what she would claim. One fact is she would never claim to have the negative evidence, have the non-supportive evidence, because that's only going to give a, as we said, she's never revealing that evidence. So even if she has it, she's never going to kind of admit to having it, because that would be just as good as revealing it, which she won't do in equilibrium. Okay, so she's always going to claim to not have the negative evidence, whether she has it or not. In contrast, the supportive evidence, remember we said in equilibrium, you're always revealing your supportive evidence. And so you are going to claim to have supportive evidence when you have it. But however, you won't claim to have the supportive evidence when you don't. Why not? Well, because in equilibrium, you're revealing it when you do. And so if you claim to have it and you haven't revealed it, then I can immediately tell you're not credible, because in equilibrium you should be revealing it if you have it. Okay, so here you get a key asymmetry in what the sender is claiming. They're going to claim to have the positive evidence if and only if they have it, because otherwise it's not credible. But the negative evidence, they're always going to claim not to have it, because otherwise they're kind of giving away their card. Okay, so that's a key asymmetry in what the sender is going to claim. Just like there's an asymmetry in what the sender actually reveals, there's going to be a corresponding asymmetry in what she claims. Okay, fine. So let me represent that same information, but now in a diagram. Okay, so here's the 4 possible types of evidence you can have. You can have positive, supportive, non-supportive. You can have just the supportive. You can have just the non-supportive, or you can have neither. So there's, let's say, 4 possible cases. Okay, so if you have both, let's say that they're both equally as diagnostic, then the true beliefs you should have for your Bayesian are something like your priors, which I'm just gonna color with gray. Okay, if you have both the supportive and the non-supportive evidence, they kind of are a wash. And the same if you have neither, it's kind of like a wash. But if you have the supportive evidence, if you're a true Bayesian, green is indicating the high state. You should now up your beliefs that the state is high. Okay, and if you just have the negative evidence, you should now downgrade your beliefs that the state is high. Okay, so this is your true beliefs in these 4 different cases. Okay, but what would your purported beliefs be? What would you claim to believe? Well, if you see the positive and the negative evidence, as we already argued, you're not going to reveal the negative evidence, and so you're also not going to claim, you're going to claim that you don't have it, you're going to claim you just have the positive evidence. So you're going to claim to be in this case, and so you're going to want to claim to have these beliefs, and so that's why these two are the same color. Okay, and also here, because whether you have the negative evidence or not, if you have the positive evidence, you're always going to claim to have the positive and not the negative. Okay, so these two bars are both this color. Okay, whereas if you don't have the positive evidence, well, you're not going to claim to have the positive evidence, but you are going to claim to not have the negative evidence. Okay, so these two bars are going to be the same color as this. You're never going to admit to having the negative evidence, but you're also not going to pretend to have the positive evidence because that's not compelling. Okay, so that's how we get these four purported beliefs. Okay, does that slide make sense so far? Because that's what this is going to be key to explaining motivated reasoning. Cool. I'm getting all my feedback from one person, because I see four in Anna. Anna is being very interactive, so thank you, Anna, for giving me the feedback. Okay. So what if we internalize our purported beliefs? So here's the last step in the argument, which is like, what if the sender actually doesn't just claim to have the beliefs as displayed here, but what if they somewhat internalize these beliefs, somewhat come to believe their own spiel? Okay. Why would that be the case? Well, one possibility is it just it helps you persuade others if you actually come to believe your own spin, and the other possibility is that you could like internalize it for now, and like we're actually pretty good at adapting based on the context, and like as soon as there's skin in the game or you have some accuracy motive, fine, you can switch back. So it's actually like fairly costless to internalize your purported beliefs. Okay, so that's kind of like the two main arguments for why we internalize, but you don't have to really trust me. There's a ton of evidence that we actually do internalize the things that we say. I mean, another way to say that is like cognitive dissonance. Again, one of the really well-known psych phenomena, really robust psych phenomena, is like when we say things that affects what we actually believe. Okay, so there's many different mechanisms that can get your purported beliefs to become internalized. There's a lot of evidence to support it, and again, the book chapter goes into a ton of this. And actually, if you've heard, Trivers has a very similar story for the idea that we internalize a lot of things that we end up claiming. If you've seen his story or his book, yeah. Okay, so fine. Tying this back into some of our phenomena that we started with. So what would overconfidence correspond to in this figure? We'll notice that in this case, you have beliefs strictly higher than the truth. In this case, the same. In this case, strictly higher. In this case, the same. So your beliefs are always weakly better than the truth. That's going to lead to overconfidence. Okay. Now, interestingly, you're not equally overconfident in all cases. Some cases you're actually like accurate, but you're never underconfident in any of these cases. You're sometimes overconfident, sometimes you're accurate. So anyhow, on average, you're going to be overconfident. Okay. So that's how we explain overconfidence. Next, we can explain asymmetric updating, the idea that you respond to positive evidence and not negative. That could be easily seen by comparing 1 to 3 and 2 to 4. So 1 to 3, the only difference between 1 and 3 is you're getting the positive evidence, and notice your beliefs are higher. And the only difference between your purported beliefs are higher. The only difference between 2 and 4 is you're getting positive evidence, and again, your beliefs are higher. But if we compare the cases where you do and don't get negative evidence, then oops. Okay, that's so comparing these two cases, in both those cases you're getting the positive, in one case you get the negative, in one case you don't. They're the same color. Same thing here. Both these cases you don't get the positive, in one case you get the negative, in the other case you don't. Same color. So you're not responding to negative evidence, you are responding positive. That's asymmetric updating. That was one of the puzzles we started with. Okay, and the final puzzle we started with is attitude polarization. Sorry, not the final puzzle. There are two puzzles about search, and that I didn't have time to get into, but one of the final puzzles is the idea that attitudes polarize when you get more information that's ambiguous. So compare the case 1 where you get no evidence, and the case here where you get 2 pieces of evidence that go in opposite directions. So in some sense ambiguous evidence. Notice that here your beliefs are becoming much more positive, much more extreme than they started off with. So your priors, in both cases, you should be about your priors, but in fact, when you get the mixed evidence, you're becoming more biased. So that's how we explain polarization. Okay, so okay, that's it for my talk. In the book, we give more examples. We give the math. We talk about internalization. We talk about some support for our assumptions, as I mentioned. We discuss some of the common threads and how the logic generalizes. And we contrast this story with the classic story in social psychology, which is we believe what we want to be true. So we talk about like how that's different from the story I just presented, and what evidence kind of supports this story over that story. And finally, another common story is that evidence is that, like, people have biased beliefs, or spin works because we're in echo chambers or don't have access to complete information. And I guess we also contrast this model with that story and talk about the evidence in our favor. So anyhow, that's what we do in the book chapter. So if you want more than I could get to in this 40 or so minute talk, take a look. And I'm ready for questions. I'm sorry if I went a little bit over.